All right, let's talk about knowing our values, unit circle addition. We want to, so we started by learning sine, cosine, and tangent of 30, 45, and 60 using our iconic triangles, our isosceles right triangle and our 30, 60, 90 triangle. Then what we do is we take those three and we translate them into other quadrants using reference angles. So we wanted to learn 30, 45, and 60-degree reference angles in all four quadrants. The goal is to recognize the values. Asking things like, what is the sine of 120 degrees is the trigonometry version of what is 7 times 8. It's knowing your times table. So we spend some extra time making sure that we know our values so that we don't have to look things up all the time, so it doesn't get in the way of trying to do other things. So let's draw ourselves a unit circle and let's talk about how we locate 30 and 60, because we're going to take those and we're going to stretch them out along a theta axis. We're going to turn this all horizontal. All right, let's begin. When you draw your circle, you want to make sure that you could find the halfway point. So we have all these points at the corners. We're on a unit circle. So our radius is 1. I spelled 0 wrong. There we go. So there's the point 1, 0. Up here is the point 0, 1. Over here is the point -1, 0. And then down here at 270 is 0, -1. To find 30 degrees and 60 degrees, those are the ones we want to focus on today, we need to know where the halfway points are. The reason that we care about this is that sine of 30 is a half, cosine of 60 is a half. So if sine of 30 is a half, remember that any point on the unit circle has the coordinates cosine theta and sine theta. Cosine is the x, sine is the y. So if I want to find the point where sine of 30, I want to use sine of 30 equals 1/2. This is the y coordinate. I want to find where y is equal to 1/2. So I'm going to go halfway on the y-axis to the point 0, 1. And I'm just going to follow that over to the unit circle. And that's going to be where we find 30 degrees. If I drop that 30 degrees down to the x-axis, that will happen at √3/2. That's harder to find on the interval from 0 to 1. It's really easy to find the point 1/2 on the interval from 0 to 1. It's really hard to find the point √3/2. So rather than find √3/2 that way, we're going to use the easy one to find the 1/2. So the coordinates at this point, the x coordinate is √3/2, and the y coordinate is 1/2. X is the cosine, y is the sine. We want to use this all the way around the circle. We want 30 degrees not only in our first quadrant, but 30 degrees in our second quadrant. So if I take that halfway up and take it over to the second quadrant, that angle will have a 30-degree reference angle in quadrant 2. What angle was that? What's 30 degrees before 180? 150. And the coordinates here, the y coordinate is the same because we can see the same y coordinate. positive 1/2. But the x coordinate is negative. The value comes from comes from the √3/2. But since we're in the second quadrant, x is negative. Then we're going to do the same thing down here. We're going to go to a negative 1/2 for a y coordinate, and we're going to look at those 2 points on the unit circle. So here's our 30-degree box. There are the 4 points on the unit circle with a reference angle of 30 degrees. So from this point down to the x-axis, 30 degrees. From this point up to the x-axis, 30 degrees. From the 150 down to the x-axis, 30 degrees. From this point up to the negative x-axis, 30 degrees. What is 30 degrees after 180? 210. So now that we're in the third quadrant, the y coordinates are going to be negative, and the x coordinates are also going to be negative. The values come from the reference angle, the signs come from the quadrant. Values from the reference angle, positive or negative from the quadrant. And let's go to 30 degrees in the fourth quadrant. What angle is 30 degrees in the fourth quadrant? 330, because it's 30 degrees before 360. The x coordinate here is back to being positive, because to get to this point, we have a positive value of x, but a negative value of y. So a positive √3/2 and a negative 1/2. We want to be able to set up all these values, all the coordinates going around the unit circle, because it's going to help us learn our values. Let's do the same thing for 60 degrees. So if we have a 60-degree angle, which trig function are we talking about with 1/2? So I've got 60 degrees, a value of 1/2. What trig function are we talking about? Cosine. Cosine is the x, so I'm going to go to where x is 1/2 and trace that up to the unit circle. So that is going to happen at a 60-degree reference angle. The x coordinate there is positive 1/2. And the y coordinate is the sine of 60, which is √3/2. I was able to locate this 60 nice and clean because it was easy to find half on the x. So for the half on the x, √3/2, that's hard to find. It's a mess to say, where's √3/2 over on the y coordinate? Forget that, we'll find 1/2 on the x. If we follow that down into the fourth quadrant, what angle are we talking about? What's a 60-degree reference angle in the fourth quadrant? 300. The x coordinate is the same. X is positive in quadrant 4. So we got a 1/2 for the x. But in quadrant 4, y is negative. Once again, kind of hard to find out where y is equal to negative root 3 over 2. So I'm going to find out where x is equal to a half and locate my 60-degree reference angles that way. Is everybody okay? What's a 60-degree reference angle in quadrant 2? I went to 2. I mess with you because I started going this way and then I'm like, oh, ha ha. So kind of not cool, man. Not cool. Over here, we're at 120 degrees. And what are the coordinates here at 120? Negative 1/2. That's how we found this one. It's negative 1/2. And the y coordinate, positive root 3 over 2, because we're in the second quadrant. Y is positive. And finally, we drop down to here in the third quadrant to find 60-degree reference angle in the third quadrant, 240. Now we're in the third quadrant. Both x and y are negative. My y coordinate is negative root 3 over 2. And our x coordinate is negative 1/2. So the way to find the 30 degrees on our unit circle is to go to where y is a half the radius. The way to find 60 degrees on our unit circle is to go to where x is a half. The reason that this works is that sine of 30 is a half and sine is the y coordinate on the unit circle. The reason that this works is that cosine of 60 is 1/2 and cosine is x on the unit circle. This seems like it's a lot to remember, but that's only because it's a lot to remember. And you have to remember all of it. All the time. In perfect detail. Dang, that's a lot. What we're looking for is we're trying to build this up so that it becomes random access memory. So we don't have to think through all the steps. The point of being in a math class always is to get to the points where you know things well enough that you don't have to do the math all the time. Your goal in math class is to avoid doing math. That's why I'm on a standardized test with math on it. If you find yourself doing the stuff that you learned in your algebra class, you're doing it wrong. The advantage that we have here is we don't really have a lot of numbers running around. We've got a 1/2. We got these multiples of 30. We got the 60s. And we got a 1/2 and a root 3 over 2. Sometimes it's plus, sometimes it's minus. And we have a lot of things that will help us out. If we remember that cosine is the x, then cosine is positive where x is positive in the first and fourth quadrant. If we remember that sine is y, then we'll remember that sine is positive where y is positive. That's the first and second quadrants. Y is positive in the top half. X is positive in the right half. Then we just learned a few touchstones like sine of 30 is a half. And then that helps us remember that cosine of 30 is the other one that goes with a half, root 3 over 2. And then since sine of 30 is a half, cosine of 60 is a half. Because the cofunction of a complementary angle, cofunctions of complementary angles are equal. Any questions? How's everybody okay? Everybody looks so very sad. So I'm like, well, you have to remember all these numbers. And I'm like, well, I bet you I don't. There's more ways that you can have support because you're armed with a calculator. So if you start forgetting stuff, it's like, oh, wait a second. Which one is cosine of 30? Cosine of 30. Oh, that's right. It's root 3 over 2. Now it seems crazy, it's like a 0.8660. We want to recognize that as being root 3 over 2. That's the decimal approximation of root 3 over 2. That helps us remember the root 3 over 2. That cosine of 30 is root 3 over 2. How's everybody okay? So let's follow this around. We've got cosine is the x and sine is the y. The thing that we didn't fill out last time is what's going on with quadrants. Now, this is where we have to definitely make sure that we're on a different path than our right triangle trigonometry, because I cannot put a 0-degree angle into a triangle. I can only put one 90-degree angle into a triangle. So if I have a 90-degree angle in a triangle, I've got a hypotenuse. I can't have another 90-degree angle for an opposite and adjacent. But by laying things out on the unit circle, we can find some stuff out. Here at this point, at 0 degrees, I got the point 10, and that tells me that the cosine of 0 degrees is equal to what? Cosine is the x. And sine of 0 degrees is the y, and that's 0. Up here at 90 degrees, we can use this point, the cosine, and the fact that cosine is x, sine is y, and we can figure out the cosine and sine of 90. What's the cosine of 90 up here? 0. And the sine of 90? Down here at 180, I can figure out the cosine of 180 and the sine of 180. And then down here that we can figure out the cosine of 270. And then back up to 360. And then we're just going to repeat ourselves. At 390 degrees, we're back at the same location as 30 degrees. 390 is the same place as 30. So our coordinates are the same. So if I ask you for the cosine of 390 degrees, take off one full circle, we're at 30 degrees. Cosine of 390 is going to be root 3 over 2. So if we learn this circle going all the way around really well, we'll know everything. Let's watch the x coordinate go around the circle. Let's start off at 0 degrees. And cosine of 0 is 1. And then what is cosine of 30? Square root of 3 over 2, which is approximately how much? 0.866. And then what is, I didn't write it down, but what is the cosine of 45? Root 2 over 2, which is approximately how much? 1 over root 2. It's exactly 1 over root 2, but how much is 1 over root 2? 0.707. So it's a little bit less. And then here at 60, what is the cosine of 60? 0.5. So our cosine gone from 1 to 0.866 to 0.7071 to 0.5. And then at 90, the cosine drops down to 0. Our x coordinate started off at 1, from your perspective, started off at 1 and dropped down to 0. And then it goes negative. The x goes negative. When we're at 120 degrees, cosine is negative a half, then negative 0.7071, then negative 0.8660, then negative 1. So we can see cosine starting off at 1, and in the first quadrant dropping down to 0. In the second quadrant, dropping from 0 down to negative 1. Then what happens in the third quadrant? Goes back up to 0. And then what happens in the fourth quadrant? Back up to 1. Remember, cosine is the x, so we watch the x go from 1 down to 0, down to negative 1, back up to 0, back up to 1. And then repeat. How's everybody okay? Let's draw a picture. Let's take that and stretch it out horizontally. So for those of you following along at home, I'm going to mark off 360 degrees. I'm going to divide my 360 into 4 quadrants. And each quadrant, I'm going to divide into 3 pieces. So here's 90. I'm going to come right through here. Here's where I want 90 to go. And I'm going to divide it in 3s. So here's going to be 60. And then we're going to have 30. Then here's my next quadrant. Once again, dividing quadrant 2 into thirds. Here's going to be 180. From 90 to 180 in 30-degree chunks, this is where we're going to find 120, which will be blue because my 60-degree reference angle. And here's where we're going to have 150, which is red because 30-degree reference angle. Everybody see my plan? I want to take that 360 and spread it out horizontally, divide it into my 4 quadrants, 90, 180, coming back up, 270, and then 360. And then each quadrant I want divided in thirds. After 180 is going to be a 210, this one here. After 210 will be the 240 at a 60-degree reference angle again. And then 270 in between quadrant 3 and quadrant 4. And then on the other side of 270, we'll go to 300. After 300, we'll go to 330. And we'll have completed 1 full circle. Now, what we're going to see here, think about what we did with the cosine. We tracked the x-coordinate going around the circle. The x-coordinate started off at 1, then in the first quadrant dropped down to 0, and in the second quadrant went from 0 down to -1, and then in the third quadrant went from -1 back up to 0, and in the fourth quadrant from 0 back up to 1. So we're going to draw a graph that starts up here, goes down, and then back up again. great picture. You see it in your eye. Let's first get the quadrants. Let's get the quadrant points. So I'm going to draw the graph of cosine. So here's going to be the graph of cosine of theta up on this axis. And down here, I got so much extra. I don't know why I have so much extra x-axis or theta axis. Let's get rid of some of this theta axis. This is me cleaning up the inside of my guitar wiring. You should see the inside of my current Fender. The wiring is like very nice and neat. And it's all behind plastic and you can't see it, but I know it's there. And it is super neat wiring. Anyway, let's draw the graph of cosine of theta at each of the quadrants. Cosine of 0 is equal to 1. So I'm going to plot a point there. Cosine of 90 is equal to 0. Cosine of 180 is -1. Cosine of 270 is 0. Cosine of 360 is back up to 1. So there's a rough sketch of what we were expecting. Starting off at 1, dropping down to 0, then to -1, back up to 0, back up to 1. Starting off at 1, down to 0, down to -1, up to 0, back up to 1. Down and up again. Very low resolution. And I also left off the fact that up here is 1, and then down here must be -1. I want to improve my resolution on this graph. I don't want to just go Game Boy graphics and draw a V, because it's not going to be a V. I mean, we're not going to get a V out of this picture. It's all round and curvy. We should expect a graph that shows up round and curvy. If we use Game Boy graphics, then it'll just be like down and then up again. You know what I'm talking about? We're going to increase the resolution. And we're going to do the same thing what we did when we were filling out the unit circle. Notice that I've got 1 and -1. And conveniently, I made it easy for me to locate where -1/2 is and +1/2 is. Does it make sense that I use blue to label -1/2 and +1/2? Why does it make sense to use blue? What angle are we going to be going for with these 1/2s and this graph of cosine? 60. That's the 2 out of 3. I said cosine. I said 1/2, and you thought 60. The 2 out of 3 just popped into your head. So the reason that we're going to use a half is half is easy to locate. √3/2, 0.8660. No, I have a dot for 0.75, but that's not 0.8660. So that's messy. At 1/2, cosine of 60 is a half. Cosine of 120 is -1/2. The next 1/2 is at 240. Cosine of 240 is -1/2. Cosine of 300 is +1/2. Now we're getting a little bit more resolution. We're noticing that we can't just draw a V shape, because the 60 and the 120 are pushing things a little bit out of shape. So notice that 60 is a little above, 120 is a little bit below. 240 is a little below, 300 is a little bit above. Here's how we improve things a little bit more. This is a little more technical. We know that the graph is going to go down and then back up again. So that means at these lowest points and at these highest points, the graph is changing direction. You're going to have to draw the graph flat at those points. So what I like to do is draw a tiny little smiley face and two tiny little sad faces to tell myself that the graph is changing direction. I don't want to come crashing into this point down here like flat. I want to flatten out. I want to just flatten out. And the same thing at the top. I don't want to just come crashing through one and go above one. We can't go above one. The range of cosine is from -1 to 1. So I want to kind of run tangent to that one. So here's how we get nice bend. These are the points that we need to get nice bend in our graph. We got to make sure that we're going to be flat any top and bottom points. And then we have these two sections between where we have the 1/2s. In between the 1/2s, connect these with a line. Just draw a line. The graph is not actually a line between those 2 points, but it is very close to a line. Then we just try to get the bend. To get the bend that we're going for is we're going to come down this line. We're going to start off in this direction, but we're going to aim to flatten out by the time we get to this point. We're going to come down the line, aim down the line, but try to flatten out by the time we get to the quadrants. So at the top and the bottom, we're trying to get it to flatten out. And our starting place is that line coming between the halves. This is a more refined version than just down then up again. Find your quadrants, find your halves, line through the halves, flat at the top and the bottom. How's everybody okay? This is how to get a nice sinusoidal graph. This kind of graph is called a sinusoidal graph. It's a little more complicated than drawing just a linear graph or even a parabola. But this is how we get nice details in our sinusoidal graphs. Any questions? Let's take a break and think about these steps. I'm going to pause the video and then we'll come back and look at sine.